Now we'll talk about the states of matter. There are three states of matter on the basis of physical classification. Here we are going to discuss in this chapter, and at the end we'll talk about two more types. So first we'll talk about solid, liquid and gas. We know that states of matter are solid, liquid and gas, and this is nothing but the physical classification. So let us discuss these one by one. When we talk about solid state, we observe that, take any example of solid. Let us take some pen, book, needle, wooden stick. We observe that we can easily draw the shape just by putting and moving a pencil around it. We can easily make the shape. You can take a transparent jar, you can take any substance, and you observe that they have a fixed shape, they have definite shape, they have fixed boundary, they have fixed volume. So any substance which has a definite shape and definite volume and fixed boundaries, we call them as solid substance. So on the basis of these, let us discuss the properties of solid. So one thing is solid, which has definite shape, they have distinct boundaries and they have definite volume. Then they are very less compressible or incompressible. That means it is not easy to compress any solid substance. They are very rigid because of strong force of attraction between the particles. The solid particles are very rigid. What about a rubber band? Because rubber band can change its shape when we stretch it. So if I ask you, is rubber band a solid? Because now it does not have a specific shape or definite shape. What will happen when we stretch it? If we stretch it, changes its shape. But again, on leaving it, comes to its original shape. So under force, we can say rubber band changes shape, but it returns to its original shape when we remove the force. So we can say that rubber band is a solid. My next question is, what about sugar and salt? When we place in different jar, it takes the shape of that jar as that of a liquid. But we just said that solid have definite shape. Then what about sugar and salt? So in this case, we can say that it doesn't matter whether we place sugar or salt on a plate or in a jar, though it takes the shape of that jar or the plate or that of a plate, but ultimately the shape of individual crystal would be same. It does not change the shape of that sugar, it does not change the shape of that salt particle. Though overall the bulk, when we talk about, it takes the shape of the container, but individually the shape of that particle will not change. So yes, again sugar and salt is matter and it is solid. Next question is, what about sponge? It is a solid, but still we are able to compress it, and we just said that solid is incompressible. So my dear students, why it is compressible, why we can compress a sponge easily? So here we can say that sponge has very small tiny holes in it. So when we press it, the air comes out and thus we are able to compress, and this sponge is compressible. So sponge is compressible, but still it is solid because it has definite shape. Then why it is compressible? Because of the presence of these tiny holes or minute pores present in it. So again, sponge is also solid. Let us move to liquid state. Liquid, like milk, like water. When we talk about liquid, there are certain important properties of liquid, and we say that they do not have definite shape. How we can come to know? If we take this liquid, a glass of water, into bottle, it takes the shape of bottle. If I place this water in bowl, it takes the shape of a bowl. So we can say that this liquid does not have definite shape. It changes its shape by pouring in different vessels. It doesn't have definite boundaries because it takes the boundary of that container. But it has definite volume. If I have 1 liter of water, by changing or transferring into another vessel, it remains 1 liter. So there will be no change in volume. So I can say that it has definite volume, just like solid, but not having definite shape. It has fluidity. Fluidity means it has tendency to flow. We know that when we pour liquid this way, it flows down. So it has tendency to flow, and thus we call liquids as fluid also. Fluid means one which can flow. So gases and liquids both can flow, and thus both are regarded as fluid. So liquid has fluidity. Liquids as compared to solids are less compressible also. We cannot compress liquids as much as a gas can be compressed. But yes, as compared to solid, liquid can be compressed much easily. So finally, liquids are called fluid, we have discussed, because they can flow. They can change their shape, they are not rigid. Let us perform an activity, and you are supposed to take different liquids. Take water, cooking oil, milk, juice, cold drink, and take containers of different shape. Take around 50 ml mark, put 50 ml mark and fill using measuring cylinder. If I ask you, is there any change in shape? Answer is yes. Measure 50 ml of any liquid and transfer. Is there any change in volume? No, it remains 50 ml only. So finally, we can say that they do not have definite shape, but yes, they have definite volume. Now try to insert when you are pouring, you observe that they can flow easily. So we can say that they are fluids, that means they have tendency to flow. So finally, we can say that liquids have no definite shape, they have fixed volume. When they are placed in container, they take the shape of that container. An important and interesting fact: the survival of all living things depends on breathing. We know that the water has dissolved oxygen into it. So aquatic animals can breathe underwater by consuming this dissolved oxygen with the help of their gills. Solids, liquids and gases can diffuse into liquids. The rate of diffusion of liquid is higher than that of solid. That means diffusion takes place for solid, for liquid and gas. But more diffusion is observed in liquid as compared to solid. That means the rate of diffusion of solid is less as compared to rate of diffusion of liquid. Now let us talk about gaseous state. When we talk about gaseous state, they do not have any definite shape. It takes the shape of the container, just like liquids. They even do not have definite boundaries, and thus gases can move very easily where they can find space. And thus they do not have definite volume, because wherever they get space, you just burst a balloon and you observe that the gas out of this balloon comes out of this balloon, takes the shape of the whole room. And if this room is open, then it goes off into the atmosphere also. Fluidity, they have tendency to flow and thus they are fluids. And the important thing is they are highly compressible. That means they can be compressed to the most. And for this, let us perform this activity. You are supposed to take these 300 ml syringes and close their nozzle by rubber cork, as we have done in this video. So here you can see that just by pressing, we observe that we have taken this syringe and it has nothing in it, only gas is there. So first thing is, just by pressing, we observe that we cannot press it to the end because it has some gas. So when I compress it, the gas can compress and reaches to this level only. But at the same time, the gas pushes back and the piston comes back. But what are you supposed to do? You take 300 ml syringes, remove the piston from the syringe from the back side, and leaving one syringe untouched, that means leave one syringe as such which has air in it, fill water in second syringe and some pieces of chalk in the third syringe. That means in one syringe we have only gas which we have left undisturbed, in second we have filled liquid, and in third we have filled solid in terms of pieces of chalk. Now insert the piston back by applying some Vaseline to it, and by applying Vaseline it becomes more smooth. Now what will happen? Now try to compress each piston one by one. What you will observe? We observe that the case of solid, we are not able to push the piston because solids are incompressible. We are not able to compress it. In the case of liquid, a very little push is possible in the case of liquid, whereas in the case of gas, as we have observed, we can compress the gas to the most. So this is very interesting activity. Perform this activity with the help of your parents. So finally, with this activity, we can conclude that the gases are highly compressible as compared to solids and gases. And gases, this compressibility factor has very important application in filling LPGs and CNGs. You know that we are using LPG cylinder for cooking our food in our kitchen for domestic purpose. Gases can be compressed because they are highly compressible. So they can be compressed into small cylinders, and because of their high compressibility, they can be transported easily. The LPG cylinder, that is liquefied petroleum gas that we are using in our home for cooking purpose, or oxygen that is supplied to the hospital, they all are filled in very compressed form, that means at high pressure. Similarly, compressed natural gas, that is CNG, is also used as a fuel these days in different vehicles, very important for transportation. So that is nothing but shows a very important property of gas, that is compressibility. The rate of diffusion of gas is very high as compared to liquid as compared to solid. Now at the end we can say that the rate of diffusion of gas is maximum, then we found in liquid, and finally we observe in the case of solid. And that's why the smell of hot cooked food reaches several meters away, sitting at in another room, and you can smell the food cooking in the kitchen. So you can easily observe and smell that food because it is in gaseous form, and diffusion of gaseous particles is very fast. So when we talk about the density, this density decides the diffusion. The mass per unit volume of substance is called density. We know the formula of density as mass per unit volume. Now the question is, can we change matter state from one form to another? That means, is it possible to convert solid into liquid, or liquid into gas, or gas into liquid, or liquid into solid, or solid into gas directly? So answer is yes, we can do that. Rather, we are doing at home. We take small amount of water, place in ice tray and keep into the refrigerator. After some time, we observe that this water changes into solid ice. So yes, answer is yes, by just changing temperature and by applying pressure, we can change one state into another. So let us discuss these two points one by one. First is effect of change of temperature. For this, you are supposed to take around 150 gram of ice in a beaker, put in a laboratory thermometer, and then place it in such a way so that the bulb of the thermometer touches the surface of ice, so that a noticeable temperature can be measured. Now you start heating this beaker on a very low flame and observe the change in temperature. You observe as the temperature increases, ice also starts melting. Note the temperature when all ice has converted into water. When the ice changes into water, or when this solid changes into liquid state, we observe that this temperature is nothing but the melting point. Add glass rod to the beaker and heat while stirring till the water boils. You observe that this liquid water on further heating changes into water vapor. That means initially ice, that means solid, changes into water, that is liquid, and further heating this water changes into water vapor on further heating. This is how we can change solid into liquid and finally liquid into gas just by increase in temperature. So you can observe that the reading in the thermometer increases, and finally we observe when the water has vaporized. My question is, can we reverse the process? That means water vapor into liquid water? Yes, it can be done. If we cover this vessel of boiling water by a plate, we observe that some water droplets are there on the plate and starts condensing down again into the beaker. So water vapor changes into water just by cooling. And if we take this water and place in refrigerator, in ice tray, freezer, we observe that this liquid again changes into solid ice. So we can just by heating convert solid into liquid, liquid into gas, and by cooling gas into liquid and liquid into solid. This is how can be changed one state to another just by application of temperature. So observe for the conversion of water in the liquid state to gaseous state. So this is our complete activity, and we are going to discuss the change in temperature also. Here this is the activity you can see. In this case, there is a iron stand that is there to hold the thermometer, and we have placed a burner on which tripod stand and beaker is there. Initially we have taken crushed ice into it, observe the temperature, start heating on a low flame, changes into liquid, note the temperature with this thermometer, continuously stirring so that thermometer gives the uniform temperature, and finally this stirrer gives us the uniform heating. Finally, on further heating, the liquid changes into vapor, again note the temperature. So this is how we can observe, how we can change the one state into another by application of temperature. What will happen when we increase the temperature? We observe that each particle has some energy into it. When we increase the temperature, the kinetic energy of these particles also increases. And once the kinetic energy increases, the particles start moving with greater speed, because kinetic energy is half mv square. So as the kinetic energy increases, its velocity will also increase. So they start moving and vibrating with very, very high speed. The energy supplied by heat in terms of burner, it overcomes the force of attraction between the particles. That means that heat, that energy given to these particles, they are there to break those attractive forces between the particles. The particles leave their fixed position and they start move freely. So we observe that when solid changes into liquid, the temperature is known as melting point, and we can define melting point as that lowest temperature at which a solid melt into liquid under atmospheric pressure. And for ice, the temperature is 0 degrees Celsius or 273.15 Kelvin. Let us talk about another process, fusion. The process of changing solid into liquid is called fusion. Fusion means we are just breaking the force of attraction of solid substance and converting into liquid state so that they move comparatively far apart from each other, and that can be done just by heating, by passing heat energy, so that the kinetic energy increases, so that they overcome their force of attraction and the particles move from each other, apart from each other, and finally from solid state they changes into gaseous state. Now when we observe the liquid, solid changes into liquid and starts changing into liquid, the temperature will stop there only until and unless the whole ice has completely melted. So we are continuously providing heat. Still there is no increase in the temperature in the thermometer. Where this heat will go? We call this heat as latent heat, and latent heat means it is the heat energy which has to be supplied from the burner or any source to change the state of substance is called latent heat. And until and unless all particles which are bonded with those stronger forces, they get broken, they move far apart, there will be no change or increase in the temperature is observed, and although that heat has been transferred to break that force of attraction, and that's why latent heat does not raise the temperature. Though we are providing the temperature from the burner, still there is no increase in the temperature of that substance. We call it as latent heat. So when we talk about fusion process, we call the latent heat as latent heat of fusion. How we can define it? We define it as the amount of heat required to change 1 kg of solid to its liquid state. So whatever be the heat has been applied, changes into this ice, changes into liquid, and this heat of fusion is known as latent heat of fusion. Let us move to next process, that is vaporization, changing of water into water vapor. So when the temperature at which liquid boil to form vapors, liquid changes into gaseous form at atmospheric pressure, we call that temperature as boiling point. And the case of water, we call this boiling point as 100 degrees Celsius, or in Kelvin it is 373 Kelvin, or more appropriate we can say 373.15 Kelvin. What is vaporization? The process of changing of liquid state into vapor state is called vaporization. So when we talk about latent heat of vaporization, it means when we convert this liquid into vapor form or gaseous form, the process is vaporization, and the heat we are continuously providing heat to this boiling water. Still the temperature is not changing until and unless the whole liquid changes into water vapor. So where does this heat go? This heat is nothing but the latent heat of vaporization and is consumed in breaking the force of attraction of this liquid state so that it changes into gaseous phase. So how we can define latent heat of vaporization? It is defined as the amount of heat required to change 1 kg of liquid to its gaseous state. Let us discuss about the units of temperature. We know that the SI unit of temperature is Kelvin, There are two other temperature units also. One is degree Celsius and other is Fahrenheit. The relation between degree Celsius and Fahrenheit Kelvin is 0 degree Celsius is equals to 273.15 Kelvin. So to change a temperature on Kelvin scale to Celsius, you just need to subtract 273 into the given temperature. Similarly, if you have any temperature in Celsius, like you have 0 degree, want to convert it into Kelvin, just add 273 to it. So using this relation, we can easily convert degree Celsius into Kelvin. Now let us talk about another change in physical state, that is from solid directly to vapor form. And we call the process as sublimation. The change of solid state directly to gaseous state without changing into liquid, we call the process as sublimation. And my dear students, the sublimation substances are very little. That means this is not applicable for all of the substances. It is applicable only to sublime substances. Like we have naphthalene balls, we have camphor, we have ammonium chloride, we have solid iodine. These are certain examples of sublimation. The question is how we can get this sublime substance. So you take a china dish, place it on a tripod stand which has beaker below it, and you take a mixture of camphor and salt into it on a china dish. Place a funnel, inverted funnel, whose upper end is covered with cotton plug. Now once you heat, what will happen? This camphor, which is sublime, has a property to convert it into vapor form. So this camphor starts converting into vaporized form. And here the temperature is more, whereas on the stems of this funnel has low temperature. So once the vapor starts coming up, they get sediment or solidify on the inner walls of this funnel. So this is how all the camphor can be easily separated from this salt, and we can get the camphor substance deposited on the inner wall. Removing this funnel and scratching the inner sides, we can easily separate this camphor. This shows that camphor is a sublime substance, whereas salt is not. And here, by using this process, even we can separate a mixture of camphor and salt, because camphor is now collected on the inner walls of this funnel, whereas salt remains behind on the china dish only. So this process shows that camphor is a sublime substance and it changes directly from solid into vapor, which again gets solidified. So sublimation is nothing but the changing of solid state directly into gaseous state. So take some ammonium chloride or camphor, put it in a china dish in a crushed form and place inverted funnel, put a cotton plug and finally heat and observe. So we have just discussed in this activity what we are supposed to do, and we observe that this either ammonium chloride or camphor or naphthalene balls, when we take in crushed form, after some time we observe that they changes into vapor form and finally they get solidified. If this vapor again changes into solid form, we call the process as deposition. Sometimes we call it as sublimation also. That means the going from solid to vapor or gas, or coming from gas to solid. Sometimes we call both the process as sublimation, but to distinguish, we call coming back process, that means gas directly into solid, we call it as deposition. And my dear students, this is again for sublime substances. So change of gaseous substance into solid state without changing into liquid, we call it as deposition, which is nothing but the reverse of sublimation. Now after discussion of this change of temperature or effect of temperature, now we will discuss the effect of pressure. So how one state can be changed into another by applying pressure. So one good example, if we compress any gas in a cylinder, we know that it changes into liquid, because the particles come closer to each other, and by just compressing or applying pressure, we are reducing the distance between the gas particles. And once the gas particles become closer and finally closer, we can convert them into liquid, and if possible, we can convert them into solid state also. So by applying pressure, we can convert any gas into liquid under certain conditions. For example, LPG and CNG. Dry ice. What is dry ice? So when we say the formula, we call it as solid carbon dioxide. It has appearance of ice and thus we call it as dry ice. Another thing is, it is a sublime substance. Sublime substance means it directly changes from solid to gaseous state. What will happen? At a pressure of 1 atmosphere, solid carbon dioxide goes directly into gaseous state without changing into liquid. And this is the property of sublime substance, and thus we can say dry ice is a sublime substance. So this is the reason solid CO2 is also known as dry ice. One, it is in dry form, it has no water particles in it, and second is it appears like that of ice, and thus we call it as dry ice, which is nothing but a sublime substance, and it is used as a refrigerant also. So this is how what we have seen, interconversion of three states. Solid on heating, that means the process of fusion, changes into liquid. Liquid can come back by the process of solidification and changes into solid. Liquid changes into vapor or gas by vaporization. Gas in turn changes into liquid by condensation. Similarly, solid changes into gas by sublimation, and gas changes into solid by deposition. And I have told you that deposition is nothing but the reverse of sublimation process.